Thanks, Kevin. So like I said, I'd like to welcome you all to day 2 of the ITSPA annual meeting. Our session, the first session this morning, will be the connected vehicle deployment session for Pennsylvania. Just a few housekeeping items I'd like to note before we get started. Number one, this meeting will be recorded. ITSPA will be making all of the recording and presentations available on either our YouTube channel or our website. So if you'd like any more information, please feel free to go and check those out. As well, you'll probably notice that you are muted right now in the meeting. Everyone will be muted who is just a participant. We encourage any questions that you have, please use the Q&A or chat function within the WebEx. The last note that I will mention is that our first presenter, Megan O'Callaghan, will be leaving after her session. So we will try to answer any questions that you may have for her presentation directly after their presentation, and then we would ask, or we'll note that all of the other questions will be answered at the end of the overall session. So with that, I'll introduce our first speakers. It's a joint presentation. Jim Katsafanas, PE PTOE. Jim is an Associate Vice President and Assistant for Emerging Technologies, a Program Manager with Michael Baker International. His engineering consultant experience includes traffic signal systems, intelligent transportation systems, connected and automated vehicles, technology deployment, and transportation systems management. Jim is serving as a consultant program manager for the 33 Smart Mobility Corridor, overseeing the project, including the infrastructure design, systems engineering, and roadside and onboard unit deployment. Jim has a BS degree from a Bachelor of Science degree of Civil Engineering from Virginia Tech, and a master's from the University of Pittsburgh. Megan O'Callaghan is the Deputy City Manager and Chief Finance and Development Officer for the City of Dublin, Ohio. She has served the City of Dublin since 2014 when she was hired as the city's Public Service Director. She has also served as Deputy City Manager and Chief Operating Officer and created the Transportation and Mobility Division. Before joining the Dublin team, she was Deputy Director for Construction for the Ohio Department of Transportation and served as the Deputy Director for Public Service for the City of Columbus. She earned a bachelor's degree of civil engineering at the Ohio State University, as well as her JD from the Capital University Law School. So with that, I'll turn it over to Jim and Megan.
Good morning, everyone. My name is Megan O'Callaghan, and we are happy to be here to share the story of the 33 Smart Mobility Corridor with you today. The 33 Smart Mobility Corridor is located in the northwest portion of the Columbus region in central Ohio. Columbus won the Smart City Challenge in 2016 and has been delivering upon that challenge ever since. And many experts in the region and local governments in the region have really been engaged in that effort and watching that effort. And the Central Ohio region has embraced the challenge and taken every opportunity to leverage the investments and the knowledge that's been gained from the Smart Columbus efforts. The 33 Smart Mobility Corridor begins in Dublin and continues west for 35 miles through Marysville and to East Liberty, and Dublin's population is around 50,000. Marysville's population is around 25,000. And it's interesting to note that Union County is also the second fastest growing county in the state. So there's a lot going on in this area. The corridor itself also is diverse in that it extends through urban, suburban, and rural environments, which provides a really good variety for a testing environment. The slide that's on your screen is important because this area has one of the largest automotive clusters outside of the Detroit metro, with Honda being at the center of the supply chain out west, and many automotive companies have located along the corridor in support of Honda. This is a thriving economic development area and economic development cluster of businesses where private sector, government, and academia partner and work really well together, and we take a lot of pride in that. We have, interesting fact is, we have one of the highest concentrations of college students in the nation. with 134,000 students. So we have the Ohio State University in Columbus. We also have an OU campus. We have 18,000 auto-related workers, 7 times more engineers than Vegas or Ann Arbor, which are our peer connected vehicle regions that we benchmark. And we also have a 25% R&D related workforce. So going back to 2014, our efforts started back then to collaborate on economic development initiatives along the corridor. We know that it's a fast growing area, and we wanted to make sure that we were being strategic and looking ahead. So we formed a collaborative group with stakeholders from Dublin and Marysville and Union County. And that group decided initially to focus efforts on leveraging Dublin's extensive broadband infrastructure and provide fiber connectivity along US 33 west to the TRC, which I'll talk about in a little bit. So in 2016, the collaborative formally organized and we formed the Council of Governments, or the COG. And that team very quickly saw success and won a highly competitive grant from the USDOT to outfit the region for connected vehicle testing. And that was just the beginning. So we saw early success there and we wanted to build upon those successes. So Odot joined the group as a partner in a big way with the fiber installation by contributing another $15 million for fiber construction. So that $15 million contribution was on top of the $6 million grant that we had received. And that was huge. Construction on the fiber then was underway. And in 2017, Odot partnered in the corridor again, and they contributed $45 million to the TRC for an expansion for a smart center. And that was big news at that time as well. In 2018, the COG hired Michael Baker as the program manager for the grant, and they led the systems engineering efforts to get the grant underway, and they've been on board leading the delivery of the grant program since that time, and they've been a great partner in the effort as well and really helped lead us through all of the federal requirements associated with delivering that grant. So next slide, please, Jim. Our 35-mile limited access open testing corridor is part of a much larger ecosystem. So you can see we have the Honda campus towards the western end of the corridor. They have 2 plants, one in Marysville and East Liberty. They produce the Honda Accord, the CRV, and another half dozen vehicles, Honda and Acura vehicles, and it's also their R&D North America headquarters. We also have the Transportation Research Center, which I mentioned as the TRC, and that is the largest independent vehicle testing facility and proving grounds in the US. And that's where the NHTSA does their testing or their crash testing on new vehicles. So that's a pretty cool facility. I already mentioned Smart Columbus to the east. And then we also have each city within the corridor. So Dublin and Marysville and also Union County, we have each of those cities with their own smart mobility initiatives that have been underway and are being launched. And that is branded as Connected Marysville and Connected Dublin. And those are the bookends to the corridor. Next slide. So now I'm going to hone in on the ATC Mtd, or the Advanced Transportation and Congestion Management Technology Deployment, the grant project. So the grant was for $6 million, and we provided $6 million in matching funds for a total of $12 million. We had private participation in Honda, where they were supplying 200 vehicles outfitted with OBUs as part of the match, which was a great partnership with private industry. And it showed that, you know, they really wanted to have a big role in the project and the initiative. The connected vehicle environment is to consist of 30 plus miles local loop fiber installation, infrastructure in the form of over 100 roadside units or RSUs, vehicles equipped with onboard units or OBUs, and connected vehicle applications, which I'll get into a little bit, a local smart network, and also multiple public and private partners. So with the numerous stakeholders involved, and there were a lot of them, there was a lot of interest in the region by academia, government, and the private sector. And a lot of those partners really wanted to engage in the project in some way. They wanted to know all about it. They wanted to learn along with the project and be a part of it all. So very early on, we realized that we needed to organize our efforts very quickly so that we could effectively deliver upon the grant. And we formed several working groups consisting of a combination of COG members and COG partners. So the COG members, Dublin, Marysville, Union County, and the Marysville, Union County Port Authority. We had numerous COG partners in Odot and Drive, Ohio. We had Federal Highway Administration, USDOT, Honda, Battelle, TRC, Ohio State University, Logan County, and Smart Columbus. They were all of our partners that we identified, and among others. So those working groups would focus on their subject matter expertise, and the expertise that we were needing at the time was in infrastructure, vehicles. Vehicles would be looking at the OBUs and the type of OBUs and the HMIs, the visuals that would be provided in the vehicles. We needed experts in the area of smart network or the IT folks, public engagement and marketing, and then also finances. So those working groups would report up to the executive committee. The executive committee would then vet the information and recommendations and formulate a recommendation that would be provided to the COG board, which would ultimately make decisions in terms of policy matters and funding. So this structure worked out really well and provided a way for many of our interested stakeholders to engage in some of those working groups and also engage in the conversation in the process, which was really, really helpful. As a stakeholder group and from the COG perspective, these are our goals for the ecosystem as shown up on the screen. So the overarching long-term goal is economic development. We really want a thriving region. We want businesses to look to this region and want to be in this region. We want them to test in the area. We want them to come to Dublin, Marysville, Union County and bring their business with them and call the area home. We want to hone our efforts on building these clusters of businesses because we know that one type of business likes to be near others of similar type. So that's something that is an overarching goal for all of our efforts. Global partnerships. We know that we want the message to get out all over the world, and we want businesses to be aware of the area. We want recognition of the Central Ohio area and all that that brings with it. We want to form partnerships. We want to be known as an area that is advanced and forward thinking and innovative, and that brings along partnerships to the area. We also want to provide an atmosphere for AV/CV testing with the TRC and all that that brings, as well as Honda. We want to make sure that we're leveraging those efforts. Smart infrastructure, public safety, and then data. Of course, we had a working group focused on data, and we know that there's a lot of data, and we want to determine what how we can best make use of that data. So one of the first efforts was to conduct a readiness assessment of the University of Applications, or universe of applications that are out there. So we didn't necessarily want to do something that was not ready for prime time. And as Jim says, we wanted to be leading edge, but not cutting edge. So we identified all the applications that have been tried and identified. And we also had to keep an eye on the objectives that we had outlined in the grant application. So as a group, we had a long list of applications that Michael Baker helped compile. We vetted all those applications and we selected from the long list of applications. We define the applications in our concept of operations, and those that are color coded on the screen, the color coding is based on their readiness. So I just want to emphasize it's really important to be cognizant of the goals that we had established in the application, because then Federal Highway keeps an eye out for our efforts, making sure that our efforts are in furtherance of those goals. So those goals become essentially minimum requirements of the grant. So we made sure that we were always checking in on our progress on those goals. Next slide. So because of funding constraints, it was determined that some of the applications would be done now as part of the grant project, and others would be deferred to the future. So those that are shown on the screen with the 33 logo are the applications that we're working towards implementing now. And those include the pedestrian crosswalk warning, curve speed warning, reduced speed zone warning, lane closure, red light violation warning, and the signal phasing and timing application. So with that, I'm going to hand things over to Jim.
Thanks, Megan. Great summary so far. So just to add on to this slide a little bit, we did include all these applications in the concept of operations. So the point was that we would be able to, or anybody in the future, be able to pick up the concept of operations and take it to the next step. So, while the funding didn't allow us to do all the applications, we at least wanted to have the level setting and the system engineering documentation to be able to move the project forward. So one of the other aspects that we had to do as we were trying to figure out, what we wanted to deploy, we really needed to have, that use case or that justification behind it. So we wanted to, determine where we were deploying the technology. So we looked at things such as, congestion index numbers, congestion information that Odot compiles to identify where some hotspots are. We also looked at crash data, crash history to identify where some of those crash clusters need to be. So as Megan already mentioned, some of the applications, the first and foremost is we had to consider safety on the project. So pedestrian crossings, and we know nationally that the narrative is that pedestrian fatalities have gone up significantly over the last 3 years or so. I think nationally the numbers were in the 4,000 range, maybe 4 years ago, and we're now in the 6,000 range of crashes or fatalities involving pedestrians. So emphasis on this project was to look at those opportunities where we had high volume pedestrian crossings and implement technology there to warn the drivers of pending pedestrian crossings, or when pedestrians are actually going to be crossing the intersection or mid-block. So we did apply this to mid-block locations. It was the emphasis. Second use case was collision avoidance at signalized intersections. And since we were going to be deploying RSUs at a lot of traffic signals, it just made sense to make this ubiquitous application deployment of signal phasing and timing, in essence, to allow for red light violation warning type application. So, something that, is obviously on the simple side of connected vehicle deployment, but at the same time, this is providing a huge opportunity to eliminate or reduce I don't say distracted driving and human error type crashes, as we've seen an uptick in those type of crashes, or a leveling off at least, where we've been making improvements and investing in improving the roadway and the geometry of roadways and to improve safety, but we can't eliminate the human error. So this is another way we can eliminate human error, or supplement human error to fix human error, I guess, by deploying signal phasing and timing, and in particular red light violation warning application. The third use case we had was curve speed warning, and the corridor itself has a mix and match of interchange types, but there is actually a large amount of we'll call cloverleaf, partial cloverleaf, curve type entrance ramps So there was an opportunity here to, look at what kind of run off the road crashes that were occurring and, emphasize those is in an opportunity to provide a warning to drivers that they're going too fast for the situation. So we know that, based on their heading, speed, and direction, that we can apply that, warning. They can be alerted in the vehicle on the OBU. But we also we also built in the opportunity to future build off of this application to include other things like road condition information and, what kind of weather's out there. So, and even hopefully in the future, gathering data from basic safety message data that we can have conditions of roadway, whether there's the wipers are on or there's ice on the road or those kind of things. So tying it into a spot weather type application as well and integrating that. And then the last use case we had was road construction and lane closure. So this one is it's not unique, but it does take a little bit more of development and background to build this. I think the Wyoming connected vehicle pilot has looked at this and has built this type of application as well. So, when we started out on this road 3 years ago, those connected vehicle pilots were still in the planning and development stages as well. So nobody had really done this one at a full scale yet. And so it was a good opportunity, to build an opportunity for providing an application that works in work zones where it can be customized to particular configurations and different maintenance operations that are needed. So that application, works very simply. After we have an application that's the ability to configure it. I'm sorry, this is actually not working properly, but the driver gets notice or the OBU gets information from the roadside that there's a lane closure or a reduced speed, and the driver's warned if, based on their direction, heading, and speed, that they need to be warned on the application. So as part of the project, one of the first things we did out of the gate once we actually got to the deployment phase is we wanted to do a pilot deployment. And really, we kind of considered this, if you will, first article testing of to make sure that we identified all the needs that we needed in the procurement. In addition to, how are we identifying sites? What's the procedures? How long does it take? What kind of coordination and other issues we have? So in the pictures and the images on the left, that's Marysville. We selected 4 intersections, and those 4 intersections are very different than the 2 intersections that are in Dublin that we were going to do the pilot. In Marysville, they're fixed time signals, 1-lane approaches. In Dublin, we have coordinated, fully actuated signals with multiple lanes. So we wanted the opportunity to kind of see how those, a less risky, before we go to full deployment, what it would look like. So we were able to use an Odot purchasing contract. That was our contracting mechanism for the pilot. What it did is it helped us identify maybe what gaps were in the purchasing contract. There was some gaps that were identified in terms of what the specifications called for, and really this helped guide us on whether we wanted to actually put out full RFPs out on the street to procure the services, or we wanted to leverage these contracts, and we decided on the former. But also some other things we found out is, the USDOT map configuration tool has had some challenges. Those things might have been figured out, but there was a little bit of adjustments that needed to be made. Using that tool and getting it to work. Once we did the field verification, we saw some things that didn't quite work out. There's nuances with vendor equipment, and even though we have an RSU specification, there's always challenges with those interpretations of that specification. For example, on this project, we had our vendor or our supplier, gave us RSUs that said, hey, they work with SPAT and MAP messaging, But when it came down to it, the left turn phasing wasn't working in their current firmware build. And even though the SAE messaging says that it should have left turn phasing information for SPAT messaging. So we ran into those kind of things. We also, we noted, and we're still not even sure, what is the value proposition of, in our application, in our scenario, what's the value add of GPS correction? Certainly if you're in urban canyons in New York City, you need a GPS correction system, but out in suburban or rural locations, do you need it? And we're still not certain on that. So we have included it in the project, but we're not certain whether what kind of value that really provides. Also, time frame equipments. If they're telling, vendors are saying, well, it'll be 8 weeks to get the equipment. Well, that might be by the time the information and the equipment gets to their bench testing facility and configurations facility, but that doesn't necessarily mean where they'll be with respect to the actual field installation itself. So in terms of the infrastructure, this is where the infrastructure is being deployed. We have signals in Marysville, all the signals, and it really is probably the first city in the country that has connected vehicle deployment at all their intersections. We have 33, we have 63 RSUs along 33, and of course, then we have some deployment in Dublin. One of the elements of the project that was important to the folks is that we had continuous RSU coverage and along 33. So we had to very carefully map out where all the RSUs were going, making sure that we had end-to-end coverage of this. And this was important for the work zone application that I mentioned earlier. So just the images of how we guided ourselves in terms of where the RSU should be placed. All right, so in terms of some of the challenges we ran into, the first and foremost was when you're looking at grants, you're not necessarily looking at details on how you're going to power all these RSU sites, 63 sites. In an ideal world, or how you typically would have done it, you would have had power drop or power service for each location. And that's obviously that ends up being the cheapest alternative 3. But it causes a lot of issues with easements and time and coordination. So we went through a whole bunch of different alternatives to really hone in on a agreeable kind of configuration. And we looked at the first 3 that are on the screen, knowing that, the desire was to have 30 amp service. That was kind of a benchmark for what we wanted at each site. What we determined is we couldn't necessarily do that. It just, given the time constraints of the project and delivery, we came up with a hybrid option, which was option 5B on the list, which allowed us to flex how we were deploying the technology or the power for the different locations in terms of how many amps, how much power we wanted at each location. Which gave us the flexibility where we limited it to 0 easements for the whole project, which was a monumental step in getting the project moving and keeping it on schedule. Also, another challenge that we have with the infrastructure is, of course, that there's no standards. Really, Odot didn't have standards at this point in time, so this was trailblazing. This was setting some of the standards. How do these poles, what do these poles look like out on 33, the 63 poles, actually 62 if you count up the numbers there, but there's a reason for that. But any regard, we ended up landing on actually using a light pole, not an ITS pole. Cost consideration, what kind of load was going to be on it was a consideration there. Also, there was no details for RSU mounting. There was no details on cabinets. So, we needed to kind of develop, what in particular was the desire for the cabinet. And of course, I already mentioned the power standards. So I'm speeding things along there. We're running a little bit behind schedule. Also, ownership was certainly an issue, and we had several versions of ownership, but the COG being a entity that didn't necessarily own the right of way out on 33, we had to come up with some challenge, address the challenges of how that was going to be handled, who was going to own the equipment. So ultimately, we landed on that Odot would own everything, but the COG had first right of refusal on specific sections of the pole, so that future expandability, there's other options to hang different equipment on the pole. But that was the whole intent, allow testers to come out and do different things. All right, so then we went to the Rsu integration stage, and we ended up with a design integrate contract award. The point of that was, really to allow us to develop as the program manager up through system requirements, and have somebody else come in and develop their specific solution, complete the system engineering documentation. So we had a team that was led by MH Corbin that was hired to do that work. And at this point, we do have all the RSUs installed, deployed, and broadcasting. So a lot of you are probably aware of the FCC issues regarding DSRC. This is a DSRC deployment. And so that brought its own challenges. We did not envision that as when we started the project. So the initial RSUs were licensed that we had installed early in the project. Those were licensed for the entire 5.9 gigahertz band. Then we had the FCC notice of proposed rulemaking that was going to reallocate a portion of that band. So we ended up in the situation where as we were deploying RSUs, that some of them were caught in no man's land. We really didn't have an opportunity to actually get any licensing for those, and they kind of sat nowhere with FCC for a long time, even to the point where when we were communicating with them, they said, well, why don't you pursue an experimental license to use the entire spectrum? Well, we did that, and then they still sat, and there was no action. So it was a very frustrating process. So what we ended up doing is we actually put together kind of a decision matrix, if you will, and I don't expect everybody to understand this or read this detail, but point being is the color coding kind of says, low, medium, and high resistance or challenges. But we ended up coming up with, looking at, what kind of concerns that we had on the project and laying them all out. And ultimately, deciding on that we wanted to go and pursue for those unlicensed locations to go to channel 180 only, even though there was some challenges, and we still consider that there's some challenges with that the FCC hasn't fully considered yet. So, earlier this year, we got to the point where we've got all the unlicensed sites licensed, and we're up and broadcasting, as I mentioned earlier. And then lastly is the onboard unit integration. So we're completing that now. We're working through that also as a design integrate contract. And we're asking for interoperability is very important. So we've asked for different manufacturers to be supplied, as well as the opportunity to look at different configurations for human machine interfaces, antennas, and whatnot. So MH Corbin actually also won that contract. So we have the OBU and the RSU integrator that can actually talk to each other very easily, which is a good thing since it's the same company. But nonetheless, that's how we ended up awarding it. So one other thing too, with respect to onboard units, is we're working through right now is concerns we have from different agency departments, and the police, for example, the school district, and how they have concerns over potentially what some of these we're calling the first article testing configuration, what concerns they might have with equipment and type of equipment, and distractions that police officers may have in the equipment. So we're working through some of those discussions right now, and we'll be working with the integrator to kind of finalize that, what the installation plan looks like and deployment plan looks like, as we've kind of rooted through some of the the candidate vehicles and boiling them down to the 200 that we're going to actually deploy in. Lastly, connected vehicle environment itself. This is just a quick cartoon graphic, but really it shows that there's other pieces to this project. There's an event streaming platform that Odot has built for us that they're going to use statewide. There's also an infrastructure management system that was included in the Rsu procurement, excuse me. And then Odot actually has their own security credential management system that they've built over the last year. So we're leveraging those other pieces and we're pulling that in to make this cohesive environment. So we're at the point now where we're completing the OBU deployment. We'll certainly be doing the verification testing with the infrastructure very shortly. And then we kick into the operational test period. Megan is going to kind of talk about the next steps for the COG.
Thank you, Jim. So I'm just going to go through this very quickly. Up until this point, the focus has been on delivering that federal grant and the 33 corridor. But what we've really done is created an ecosystem that it's a workforce and a talent driver and recruiter for businesses. So we are always looking ahead to the future, and we wanted to be strategic and build upon those successes. So we went through a collaborative branding effort, and we recently have rebranded ourselves and have expanded from 33 Smart Mobility Corridor to the Beta District. We recently launched the Beta District and are starting our marketing efforts. The Beta District, it's a region where private sector, government, academia, we all work together to safely test and deploy technology in a real world scenario. We have a ton of partners, and all of this information is on the website. I urge you to check out the Beta District website. You can see all of our partners listed on the website. It's been a tremendous effort. We interviewed many of our stakeholders, and I believe that I've thrown out some kudos to most of our partners at this point in the presentation. And if you could jump ahead a couple slides, Jim, go to the real world environment. We have within the Beta District, we have connected Dublin, we have connected Marysville, and we have the Smart Mobility Corridor, and we have rebranded all of those initiatives to fall under the umbrella of the Beta District. So with that, I'm going to wrap things up and just thank you for your time. And again, I hope you check out the Beta District and all it has to offer. If you have any questions, feel free to ask.
Thanks, Megan. Thanks, Jim. Just because we know Megan has to run, I saw that there was 2 questions that came through. One of them, and Jim, this is for you. Are the contracts that you mentioned for the RSU and OBUs, are they low bid or quals based or for best value?
They were both best value contracts. So we wanted qualifications of the team, and as well as we did have a cost component as well in that.
Okay. And then the other question, which came through, I think, before you started touching on it, but if and when USDOT decides to move to Cbdx, what challenges do you see in updating the applications?
Well, I mean, we don't know. We don't know that answer fully. We hope that because LTE Cbdx is based on the same message sets from SAE, we're hoping that the application conversion will go smoothly. And we did, the way we deployed the project, we actually have roadside processing units. So things are occurring with the roadside units themselves are really just broadcasting. They're just radios. So we have the opportunity to swap those out, and hopefully the back end of it is going to be a little bit more seamless as far as the applications themselves.
Okay. Thank you, Jim. Thank you, Megan. As I noted, Megan will have to run, but if there's any other questions, please feel free to post them in the chat and we can follow up and get back with you. So with that, we'll move on to our next presentation. This will also be a co-presentation with joint speakers. We have Wasif Mirza and Kevin Hayes. Wasif was appointed to the position of Director, Division of Mobility and Systems Engineering in January 2014 for New Jersey Department of Transportation after serving as the manager of this unit since October 2011. Wasif oversees a staff of 42 people and an ITS budget of $73 million. That includes ITS mobility and systems engineering, along with ITS signal system and congestion relief project and programs. He is responsible for providing the planning, design, construction, review, inspection, and maintenance of technology-related projects and intelligent initiatives. Wasif and his staff also provide for engineering services along with technical support for ITS and smart initiatives, vehicular mobility during construction, deployment of smart signal systems along the New Jersey state corridors, connectivity and communications systems deployment and management. And then Kevin is a manager of advanced transportation systems in the group at Jacobs, based out of the Morristown, New Jersey office. He has served various agencies throughout the state of New Jersey as an ITS project manager, engineer, integrator, and contractor for more than 18 years. Throughout his career, Kevin has helped each of these agencies achieve innovative ITS design and deployment solutions in areas such as adaptive and coordinated traffic signal systems, communication networks, ITS device deployment, transit signal priority applications, and most recently, the project that we're going to discuss, the New Jersey Connected Vehicle project. So with that, Kevin, could you make me the presenter?
You should have the privileges, Drew.
Okay, so I'll share my screen. That's the wrong screen.
It looks good.
Oh, that was correct?
Yeah.
Okay, and with that, we'll turn it over to Wasif and Kevin.
Thank you very much, Drew. Good morning, everybody. I've been told that my computer mic system isn't cooperating very well. So if you feel that I'm shouting or leaning towards the screen, that is just to comply with the request. So I hope I'm loud and clear. If not, then please put in the chat box and I'll try to do something different, maybe sign language. But anyway, good morning, everybody. My name is Wasif Mirza, and I'm the Director of Mobility Engineering, also known as ITS, in the Division of Traffic Operations, System and Support at New Jersey Department of Transportation. I'm also honored and grateful to share the limelight of the virtual stage of the camera time with my worthy colleague, Kevin Hayes of Jacob Engineering, who splits his personal and professional life between Jacob as in family. Approximately 25% with the family, and the remaining 75% is dedicated to my unit at DOT. As an official of the state agency, I take great pride to acknowledge the services of professional consulting firms that lend the support and services to make my life easier. Next, I want to thank the organizers of this event for inviting NJCAV design team to this event. We are honored, humbled, and elated for getting this opportunity, and I want to thank them for their hard work, dedication, and efforts to put this event together. Lastly, I want to thank the audiences and viewers who are logged in to view our presentation. Hopefully, we can provide some relevant information by sharing our experiences of challenges, hurdles, disappointment, and successes regarding the CAV initiative that NJDOT design team is currently leading. Next slide, please. This slide lists the topics that we will discuss during our presentation. Each of these topics is extremely complex and detailed subject that we will attempt to cover in minutes, which in real time took months and years. I will start off with the project background so that it becomes easy to relate to the unique challenges, difficulties, issues, and hurdles for us. Approximately 4 to 5 years ago, when FHW was extremely aggressive in encouraging the states to initiate a SPAT and MAP challenges, many progressive states complied and earned the bragging rights and the privilege to be in the SPAT club. I recall FHWA had prepared a US map of all the states with different color assigned to the state that had earned this privilege. Jersey was not on it. I recall either 2018 or 2019 was the TRB, when every session of every day was nothing but CAV. And for some reason, almost all the session I attended started off with this map displayed, which was always unsettling for me and my colleague. That year, TRB was so packed with CAV sessions that my colleague from New Jersey joked that even the halal food truck vendor selling shawarma sandwiches on the street near the DC Convention Center were talking intelligently about CAV. Unfortunately, New Jersey was not actively pursuing this. So you can imagine a lot of pressure building up. As the SPAD and MAP challenges required deployment of devices through an actual project, there was a lot of prep work and prerequisite needed on our part before any serious discussion with the management to financially support the project. To sum it up quickly, to pick a starting point on where to begin, we started to determine what our existing capabilities are, or capability maturity, and a detailed system engineering process, which we'll discuss later. This is just to determine areas of critical gap on what is needed and what do we need to do on what do we have in terms of capability. And of course, we identify many critical areas of deficiencies in the existing standards, specification for planning, design, construction, operation, and maintenance that would require evaluation and assessment, followed by changes, enhancements, modification, and amendment to become CAV ready. My worthy colleague will describe some of the major areas of enhancements, identifies a requirement, and we will briefly discuss those, such as intersection requirement, hardware requirement, data handling requirement, testing, and acceptance. He will also go into the lab or the workshop, or the good old-fashioned bench testing needs and purposes, and the initiation of the design under controlled condition in the work. Highly recommended for all my worthy colleagues that are from state agencies. Kindly do this. Actually test equipment in the lab in a controlled environment before you do it. Then this will be followed by the field deployment. We will share the lesson learned and the upcoming initiative, which is necessary to attract the interest for the consulting community, and then the time for QAQ. Next slide, please. As I mentioned earlier, while other states were executing pilots and proof of concept project, New Jersey ITS team was busy leading several efforts such as developing consensus for mainstreaming CAV into NJDOT project pipeline process by developing planning strategies and strategic plan documents, design standards, design requirement, specifications, protocol and procedures, testing and acceptance methodologies to construction execution planning. I will briefly describe some of those efforts in the next. The list on the slide describes some of the products or deliverables, standard processes and procedures that are worth mentioning. There were many more other changes, just like any other states. We are only listing some of the majors. Hardcore ITS engineers and the viewers and any design engineer working on any technology project would agree the best starting point for any technology-heavy project with completely new and unknown performance expectation or goals and objectives that are still not fully developed would be a detailed system engineering process, logical multiple stakeholder. Slide 4, which we will follow, lists all those stakeholders. As a result of the SE process, there were many upgrades and changes that we had to implement in our practices. The most basic is the controller cabinet. To accommodate the needs of all the equipment and devices, you must upgrade your cabinet. P77 cabinet is in response to developing the requirements for the upgraded equipment. The signal cabinet for the CAV is now full-fledged data center with extremely sophisticated and complex equipment. Similarly, the plan specification and standard terms and conditions for execution projects had to be developed. And lastly, a back-end software that is one-stop shop for managing all your data needs at the TOC. Currently, we are using Cisco Kinetic. Next slide, please. This is a list of all the stakeholders. As you can see, several departments for NJDOT itself, capital program management, design, electrical maintenance were within the DOT. We also interacted with the ITS group in the Port Authority as they are working very actively with the New Jersey Transit on the automation of buses and installation of devices for connectivity for XBL project. That's drive-by-wire, by the way. The 3 MPO, North, Central, and South, primary responders such as fire, police, and MT, and the trucking. Next slide, please. Another group worth mentioning was the CAV Committee that was formed under the New Jersey Transportation Agency Initiative. Group comprised of agencies listed on the slides, which are some of the major transportation agencies in New Jersey, directly managing the traffic management and operation of highway network facilities between PA, Delaware, and New York. My unit led the effort to initiate a CMM effort. If you haven't done this yet, kindly, I highly recommend do a capability maturity matrix to establish the baseline condition to determine the gap of where you want to be and where you currently are. Another big achievement of NJTAP CAV Committee strategic deployment plan, which listed short, medium, and long. Slide, please. Here's the CAB plan, so the P77 cabinet, which was developed after many technical discussion. with the electrical engineers of the Traffic Engineering Bureau, ITS engineers, electrical maintenance staff, vendors, and suppliers. I'm not going to go into detail other than describe some of the major changes that we had to incorporate to ensure the new technology and the devices for the new technology as we know them today. By the way, everything is changing so rapidly. I'm already looking at ways to phase out RSUs that I haven't installed yet. Anyway, fully equipped, the equipment and the new cabinet makes them extremely expensive compared to their predecessors. One cabinet got wiped out, and this is not a CAV cabinet, by the way. It was about $35,000 to. Some of the significant features of the cabinets are the multiple racks for storing the multiple switches and servers for edge computing, which makes it necessary. Your ITS group, your security group will be breathing down your neck on beefing up the security of the locks themselves. So for edge computing, the multiple power outlet, multiple jacks, interfaces for inserting external devices, nightlight, laptop tray, multiple conduits. I'm sure you folks have all done a lot of these. Notice the extra cabinet attached to the side. That is for storing multiple battery banks. You may question why there is no generator hookup. There is a generator hookup, but as most of you would know, the power from the generator is not a clean power. It's got a lot of fluctuation. Next slide, please. One of the most challenging and difficult tasks was to get some feedback. Notice I've not used the word approval from our colleagues in the structural unit for recommending on installing or attaching any additional devices on the existing pole. As the viewers may know, FHWA is now requiring compliance with the latest AASHTO standard, one of the most obvious reasons to be resilient to severe weather-related events. So consider a new aluminum pole that is approximately 30-40 years old. The constant loading of a signal head hanging on the free end of the cantilever would induce permanent fatigue and stress. And structure was very reluctant to even issue permission to birds to sit on the cantilever, so let alone my unit. Anyway, this slide is of our standard that was developed after much coordination with the structural unit. Perhaps you do not have this issue. Slide, please. Here's a listing of the applications that were prioritized as part of the system engineering process with the 30 stakeholders. Most of you in the viewer may also know that slowly and gradually the vendors are developing these applications, and most likely the RSUs of the near future will come equipped with most of these applications baked in. So with this, I will now hand over the baton to my worthy colleague, Kevin, who will walk you through the remaining of the presentation.
Okay, so I'm going to go through the lab portion of the presentation, which was the meat of the project. To start off, I just want to discuss the project team. This was a true private-public academic partnership. NJDOT was obviously the prime partner and the benefit of most of the results out of the project. But we also had New Jersey's Office of Information Technology. As this equipment is highly network-centric based and need of security and other essential networking aspects, they were a key member. Cisco represented our primary vendor for the communications equipment, as well as they also supplied the major IoT data management hardware and software that was used in the final solution. Rutgers and TC&J, as well as giving us a physical home to house the lab, also provided academic documentation and app guidance and other items from their particular venue. Jacob served as both the program manager for CAV, as well as for the primary integrator of all of the equipment and various pieces into one cohesive system. Next slide, please. So the first thing we had to look at was where we were going to do this and what physical requirements were required for deployment. This project was a true stem to stern analysis of CAV. Everything from how applications would work, software, on the virtual side, but also on the physical side. How do I physically mount it? What do I need for cabling? How does it interface with physical traffic signal equipment? So in that, we had criteria we looked at for the intersections. In particular, things like space, conduit fill, obvious structures. We wanted only fiber-based communication because we wanted reliable, high-speed communication all the sites. And with this having occurred during COVID, it ended up being more important than we figured to be able to provide remote access to equipment for various vendors and personnel. But we also looked at the physical intersections and their locations. We were trying to determine a good variety of sites where, similar to areas near large parking lots or near commercial facilities. We looked for 2 intersections that were close together. We tried to find very wide, very small, a good variety to really test out how the equipment would operate statewide. We used both closed loop intersections, and we also particularly targeted getting adaptive intersections onto the project, because that was a key function of this project, was to integrate SPAT and MAP with the DOT's preferred adaptive vendor of SCATs. Next slide, please. The hardware, we tried to keep a good variety. For traffic controllers, we tried to use a large sampling of the controllers that the DOT currently has deployed or is looking to deploy in both isolated, closed loop, adaptive, and both ATCs, 2070s. We have TS2 controllers, the whole gambit of different configurations of controllers. On the RSU side, we tried to bring in as many vendors as we could, both CV2X and DSRC, because halfway through the lab, the ruling did come out, and we did also switch to bringing in CV2X in order to test both. Same thing with OBUs. We tried for multiple vendors, and this was an entire spiral development process. Everything was tested standalone. Then we'd bring in a piece, then we'd bring in a piece, then we'd bring in a piece. So at any point we found a failure, it was easy, quick, and ready to find the problem, get the vendor they need the responsibility with it, get the integration complete, and move on. The last piece we brought in was we are using Cisco's Edge Compute OIT data management system. They provide both integration and data management support for various pieces of hardware. Next slide, please. Okay, so once again, the project methods and data requirements. So we primarily targeted SPAT with this lab effort. As a result of SPAT, we inherited MAP, because obviously one can't operate without the other. And then we also brought on travel information systems, messages, because travel information messages obviously are the heart of most other applications, because most of them boil down to the basic technology of issuing out a TIMS message. Basically, if you can do a TIMS, most of the other messaging systems seem to be readily doable. We also add in the basic safety message, as that is the great return payload for providing this data out to the world, is getting back that critical information on the cars and all their various things for both feeding apps and feeding future design development, data acquisitions like that. SCMS was a very critical portion of this project. As NJDOT does not own the full communications chain, because they do not own all the vehicles that will pass through the system, SCMS security was critical for protecting DOT's infrastructure and data control systems. Next slide, please. So once again, this was a spiral process. So we started by building everything out in the lab on physical benches, exact duplicates of intersections, exact duplicates of communication systems, running active timings. We did start with basic timings and then moved into physical intersection timings. Everything was tested both with and without the Cisco environment. And then there's a exact mock-up of the Cisco environment was built in the lab. Everything in the lab would later be deployed to the intersections. The physical lab equipment used would go to the physical intersection. So everything would remain constant throughout the entire process. Next slide, please. So in the lab effort, we identified that not everything was compatible with everything. Despite manufacturers' claims, certain vendors only worked with certain vendors. without the Cisco system in place. The Cisco system in place did prove to be somewhat of an equalizer in some cases. In some cases, there was nothing they could do. But we were concerned that should anything go wrong with Cisco, we could always fall back to a direct communications method. So we developed this matrix of the compatibilities and move forward to the next phase using the items that was most compatible going forward. Next slide, please. So then we move to the field deployment. In the field deployment, we primarily use traffic-aware controllers because both the DOT's existing SCAT system and DOT's existing closed-loop system is based off the traffic-aware system. Primarily 2070s, but the traffic-aware commander is the current replacement, so that was put out into the field. We were able to integrate a SCATS intersection into a RSU platform for several vendors. So that is, as far as we're aware, the first SCATS deployed CAV transmitting intersection that we know of. And once again, any RSU that was not compatible with SCMS did not move to the field phase, because once we were in the field phase, we were accessing DOT's live network, and protection of that network had to be paramount in this project. So if you were not able to pass the SCMS test, you simply did not field deploy. This project was both DSRC and CV2X, as I did touch on. Halfway through the project, the notice came out, but we still wanted to deploy DSRC and CV2X. Each intersection has one of each, and this allows us to gauge the area market to see what primarily is out there, if anything is out there, DSRC or CV2X, so we know further the value we're getting back if we only say can deploy CV2X units. The OBU used in the field test was the CompSignia unit, mostly because it had the most easy and readily usable testing features over the other units that we tested. Next slide, please. So out of the results we got out of both the lab and our field testing. Once again, not all RSUs are compatible with everybody. There is a lot of partnering, proprietaryship between them. We only found 2 RSUs that could actually work with the SCAT system, and they actually work by 2 completely different methods of communication. Not all RSUs are SCMS compatible. Some are, some are not. Some work well, some do not work well. Communications, we were able to get everything working and integrated. Both CV2X and DSRC are transmitting at intersections. There is no interference between the 2. They all seem to be working readily well. There's issues between traffic controllers and, like I said, and RSUs. The IoT data management platform has proved to be helpful in bringing in some vendors that we would have lost if it was not there due to compatibility issues. And in some way smoothing out some of the controller issues that we have run into. They're going to be able to assist us with. Next slide, please. So we did have a whole bunch of lessons learned so far from the testing we've already accomplished that we're already pushing through to existing design projects. One is with the method SCATS uses as an adaptive system with a central server-based calculation matrix. We are experiencing a delay between the physical display of the signal and the virtual display inside an OBU. We're currently working through that issue. We're hoping to get it resolved. The delay has been found to be minor to significant. We're working through it. We've run into an issue with map size. Several of the RSU vendors have put caps on the size of the maps they will emit. And part of that map is actually taken up by the SCMS certificate. This has caused, due to certain roadway speeds, that the map may not be big enough to actually deploy certain applications. Another issue we're currently working through with all the vendors, and we're hoping to get a resolution to. One of the largest issues we've run into is the SEA standard until 2020 did not admit all all phases a controller can utilize. In particular, in the state of New Jersey, heavily uses pedestrian phases and heavily uses the overlap phase inside controllers. These are not omitted in the current 2016 standard. We're working ways around it, but ultimately, apparently 22 will fix it. So we're also working with several vendors to see if we can get early deployment of 2020 SCA standard. I will now turn the presentation back to Wasif so he can go over the next steps in the future of CAV in New Jersey.
Thank you, Kevin. I'm assuming my speech is being transmitted properly. In other words, there's no mic issue, so I'll continue. So the slide 19 provides some of the existing workload in the CAV. Very proud to say all of these are actual construction projects and not planning or concept development. CAV technology is being used, such as a 30-mile long one corridor. Next slide, please. This is the Route 1 corridor. This was combined with section of Interstate I-295 for the wrong-way driving location. This is a new initiative for New Jersey where an RSU will be installed beside the traditional wrong-way driving. Consider this, the penetration rate of RSU with DSRC is low to begin with. Those of my worthy colleagues that are in the viewers, they would attest to that. You do have some penetration at the moment with RSUs from the vehicle with DSRC, but now change that to Cbdx. That makes it even less of a penetration rate. Now couple that with New Jersey DOT requirement of SCMS with ISS. You have absolutely no public vehicle with these specifications. If you're going to put a wrong-way driving warning deterrent system, it is necessary to have a CAV broadcasting the information that someone has driven in the wrong direction along with the traditional deterrents. So that's what we have done so far. So the Route 1 project is the one where it's an existing adaptive signal system, which is SCADS. Kevin in the previous slides mentioned a big accomplishment. SCADS, for those of you who do not know, is not an American software. It is extremely versatile. We did a very detailed system engineering process and we had selected it. So this wasn't forced upon us in any way, shape or form. It wasn't a decision made in a vacuum. Several states do use it. I think Michigan is one of the bigger states, but it's extremely difficult when you want to integrate American devices with a software which is not. It's very difficult. I'm also very proud to say I had a very productive meeting with the Australian government yesterday, and there's a plan with the SCADS vendors, with the SCADS actual developers. This was developed by the Sydney government itself. So they reached out to us, so we're doing it. They're willing to make, which is a great. So Route 1 has fiber backbone. Most cabinets are already integrated. Ethernet switches will be changed to Cisco edge devices. So I was mentioning, Kevin had indicated the success that we had with SCADS on broadcasting SPAT and MAP. That is an accomplishment because it's an adaptive system. Those of you who are familiar with adaptive, you would several challenges because a server is deciding what the new timing plan would be. They are not, unlike broadcasting SPAT for a time of day plan, which is literally a piece of cake. If I give you a time of day plan and you've got a good stopwatch, you can literally tell me what the signal indication would be in Afghanistan's, all right? Seriously, for all practical purposes, that's how predictive it is. But adaptive is kind of a Wild West. You don't know what the server will decide, what the algorithm will decide. Next slide, please. This is another project which is Route 4322. This is also an adaptive signal project. We are putting RSUs in here, and it's again a project. Caution that I would like to indicate to my worthy colleagues, especially from state agencies and as well as the consulting community. Beside the bids that are coming in high due to the cost of material, anything with networking chips and IC components are badly impacted in the delivery schedule due to disruption on the supply chain. So we were told for edge computing devices, which is Cisco, by the way, or we were dealing directly with Cisco. We were told that there would be a lead time of maybe 2 to 3 weeks, which has now changed to 3 to 4 months, which is now changing to 6 months. So just be aware that your bids will come out higher because in New Jersey, at least at the moment, there's a lot of construction going on, so the contractors are not very hungry. B, that's not necessarily true, but the bigger issue is the bids are coming higher because of the disruption in the supply. So just wanted to throw that out there. Next slide, please. So with this, we have concluded our presentation, and hopefully we've stayed in our time slot. If we have exceeded, I apologize, but it's open now for Q&A. So I will stop my video. Do you want to take over, Drew, or do we stay on, or what?
Yep. Thank you, Wasif. And so I did see there was a few questions that came in. We'll get to those questions at the end of the overall session. But right now we're going to move forward with the next presentation within our session, which will be Alan Davis. Alan currently serves as Assistant State Traffic Engineer with Georgia Department of Transportation and oversees SIGOPS Traffic Signal Operations and Maintenance Program for the department. Alan also leads the department's effort in connected vehicle deployment and application. Alan is a registered professional engineer in the state of Georgia and South Carolina and a professional traffic operations engineer. Alan serves as a member of the Signals Technical Committee with the National Committee on Uniform Traffic Control Devices. Alan is a 2006 graduate of the University of South Carolina with a Bachelor of Science degree in civil engineering. So with that, Alan, I'll turn it over to you.
Thanks so much, and thanks again for having me here to share our experiences and what we've been working on. It's great to hear stories from our colleagues across the country here and what they're going through, and commiserate a little bit some of the struggles and issues that have been going on in this space. But hopefully I can shed a little light on what GDOT has been doing in this world, some of our successes, some of our challenges, and especially looking forward to what we're going to do in the CV2X landscape. Just to give a quick little overview of where our particular program is and what we've been working on the past couple of years. We really all got started in the, as it was said, the SPAT Challenge Club. That was a great opportunity for us as an agency to dive into the space, to get an understanding of what we may need to do to support connected vehicles, to understand our role in that world. Do we as an agency need to participate in it? And if so, what of our system and infrastructure we needed to do to modernize, update it, and be able to support applications like this. And so we jumped into that challenge, 20 intersections in all 50 states by the year 2020. We had 2 corridors we identified we were going to deploy on for 54 intersections total. And that first deployment went live in 2018. We targeted, obviously, traffic signal-based applications, and we learned a lot. And one of the important things we learned from that is we could actually scale our this kind of technology pretty decently across the whole state based on previous investments we've made in our ITS and traffic signal infrastructure. So that's what we did in 2018. We looked at it not just being a pilot, but we wanted to do a programmatic deployment. We found that it was interesting to deploy this on 2 corridors, but we really thought that in order to move the needle with safety and mobility and prepare for this connected world, we wanted to embrace a regional deployment of this. What would it look like to have the entire metro Atlanta region equipped with this infrastructure on every major highway, not just 2 corridors? So we looked at deploying at 1,600 intersections across the region. And we added in additional applications based in the traffic signal space of emergency vehicle preemption and transit signal priority as tangible applications we could leverage this technology with. In 2019, we were fortunate to be awarded a Usdot Atc Mtd Grant. That was, in a lot of ways, we felt that USDOT buying into our vision of this broad deployment of technology. At this time, it was just DSRC that we were putting out there. And so we had this funding source from the USDOT to expand that to meet our 1,600 intersection goal. In 2020, we actually entered into an additional partnership with the regional MPO in Atlanta, the Atlanta Regional Commission, who wanted to bring in federal aid and local match dollars to actually expand out even further this intersection-based deployment. They had a goal of 1,000 additional intersections equipped with this technology, with public sector fleets as the target application point for using this infrastructure. So now we were looking at not just 1,600 intersections, but an additional 1,000 in the year 2020. That's been an exciting partnership we've kicked off and have run in that GDOT is managing with our local agencies. And that was the introduction of a broader CV2X deployment for us, which I'll get into more in a little bit. And lastly, in 2021, this past year, our current year, we were fortunate to be awarded an additional Atc Mtd Grant, this one being a application-focused grant that looked towards deploying infrastructure for emergency vehicle preemption to support incident management, incident response in downtown Atlanta. So we're excited to have all this going on. It's been a hard to believe that just 4 years ago we had our initial turn on of these devices to get to where we are right now. And what that looks like is through all of these efforts and partnerships that we have going on throughout the whole state, over 2,600 RSUs at intersections that will be deployed to these programs. That's taken a little bit of a pause at times due to things like pandemics and regulatory action, which I'll get into a little bit, but we're still moving forward with that initiative to meet those numbers across the state. Just to give a little impact of what that path looked like and what things like FCC action did for us, I mentioned we started in 2017 of our phase 1 pilot and quickly expanded out. And we had gotten up to over 650 intersections equipped and operational with DSRC RSUs when the FCC began its action and took its initial votes back in November 2019. It really made us have to pause and step back and say, what does this investment look like for us? Do we need to pivot? Do we need to back down? Do we need to pause? Where's industry going? Where are the regulatory winds going? That was a lot of deliberation for us. And so we had to think through that. And ultimately, we have been following the trends and paths of where that action will take us and are currently in a state of deploying both radio technologies on our deployments, now winding down our DSRC deployment. Overall, though, what the state looks like and where these things are right now, the blue lines on this map that you see are representations of our initial 1,600 intersection corridors where these DSRC RCUs are deployed, largely focused there in Metro Atlanta. Over in the western part of the state, there's a section over there that is part of a partnership with the Ray C. Anderson Foundation and the Ray on I-85 and Panasonic. I'll talk a little bit more about that in a minute. And then down in Savannah, in the southeastern part of the state, you see we have some deployments there that are focused on freight and freight priority type applications. One point of bragging I'd like to make too about us as an agency is that almost 99% of every traffic signal in the state is running on our software platform. And each one of those intersections is what you would call CV ready. Based on our architecture and framework, it takes a little bit of hardware, namely an RSU installed intersection to make it be able to broadcast SPAT and MAP messages from it. So we're proud of that and feel that it puts us in a great position for scaling out this as connectivity demands increase. What that framework really looks like for us, though, is we see really two paths of information from a signalized intersection specifically and connected vehicles in general. One path is the path of information that it's time sensitive. It needs to get there in that instantaneous method, and passing through network communications and things like that adds too much latency to it. These are your safety grade applications, things that support safety applications in vehicles and things like that. We see that as the primary means needed for these RSUs to be able to broadcast that information. So we continue to support that through that infrastructure. There's also a host of applications in the world a lot of smart people have developed that aren't necessarily time sensitive or don't need the same latency requirements that a safety application may need. These are more mobility things. And so we also see a necessity to provide that path of information out to ourselves, third-party partners, private companies, research institutions, things like that can use this kind of information for a whole host of things, whether it be for route optimizations, for mapping algorithms, all the way to digital twin applications at research institutions and things like that. We also have the means to be able to support that path of information. And so we really try to let these applications delineate how the information needs to be delivered. And that drives a lot of our infrastructure decisions. As we deployed this ecosystem, we wanted to make sure we were using it and prior to a private fleet being out there making use of it our own. So we've deployed and operated 4 different realms of applications. I mentioned emergency vehicle preemption, transit signal priority. We see connected vehicle technology being a great answer to the regional interoperability needs for transit agencies in the Metro Atlanta area and across the state as a means of communicating to infrastructure to request signal priority. Same goes for freight, providing freight priority at intersections where it's deemed necessary or viable, and also just generic information about the conditions of roadways, things like at-grade crossing blockings. And again, our basic signal phasing and timing. We did a fun demonstration of optimal green speed where we were broadcasting based on the trajectory of a vehicle and the green band on a signalized corridor, the minimum speed a vehicle needed to drive to clear a sequence of green lights in a coordinated fashion. So as a signal person and traffic signal person in background, I took a lot of fun in that one, and also seeing where we had a lot of bad signal timing out there. Just to target a little bit on what these actual application deployments look like for us. This is our transit signal priority. We partnered with our state road and toll authority, who operates regional express buses that start from outside of downtown Atlanta and make their way in and out every day. This is a great opportunity for us to take one of their least reliable corridors and
Hey everyone, bear with us for a second. Some of you may have lost audio and video from Alan. Sorry, everyone, just bear with us for a second while we try and see if we can get Alan back on the line. All right, everyone, not trying to get Alan back on the line, but I guess in the meantime, I'll quickly go to some of the questions that we had. Kevin and Wasif, we did have a question for you, just wondering what Cbdx, if any, data you've seen so far. I don't know if you could speak to that.
Sure, Drew. I'm not going to start the video just in case, because the message that's coming up is that there's a bandwidth issue on the video. So I'm assuming, Drew, can you hear me?
Yes, I can hear you, Wasif.
Okay, so the question that you received was pertaining to the type of data that we have seen coming in.
Cbdx particularly, Wasif.
CB2X, correct. I will let Kevin join in and obviously give a more detailed response, but I will indicate I will describe what I know. So as I described in my PowerPoint slide, we started off with the RSUs with the DSRC. So we knew that Drew was kind enough to actually take us out to the Pennsylvania Turnpike. They had deployed RSUs couple of at least a year ahead of us, and there was a lot of penetration rate that they were getting, a significant amount. In other words, it wasn't huge, but it was still a lot that you could get some feedback and feel excited about getting some response back. When we started as Kevin pointed out, that the FCC ruling came out and everything was switched to Cb2X, getting the licenses was a huge pain in the neck. Anyway, we switched to that. So we were still hopeful we'll get the data. The big kick in the teeth is when you require any transmission that's coming into the radio receiver has to have a credential certification. That wasn't in the state of New Jersey prior to this. So it just cuts off everything that doesn't have those credentials. So I will let Kevin speak and chime in, but as far as I know, Cisco, by the way, is the backend software that could tell us what the chatter is. We have, I don't think it's anything coming in because of the last requirement, which is the SCMS, which is the Security Credential Management. Because ISS is the new vendor that we have, or the vendor that we have. Once you put that in there, and if the RSU messages coming in are not equipped with those certs, they would be dropped. So Kevin, please chime in and provide information so we could provide some information regarding what the question is seeking. If there is any kind of.
Yeah, so as far as CV2X goes, once again, because of the SCMS, no unsecured data is passing from the RSU to Cisco if it doesn't have a security credential with it. In the actual RSUs, we're seeing a handful of denied BSMs from time to time. So there's obviously some out there, but I couldn't give you an exact percentage because obviously we're the only ones that have the SCMS credentialed OBUs currently in the state. But we have seen occasionally some stray BSM messages that didn't come from us that were denied because of the SCMS. So hopefully that gives you some understanding of the topology of CV2X that we're seeing.
Kevin, if I'm not mistaken, had we deployed the first intersections in the border of New Jersey with New York, would we have seen a lot more DSRC with SCMS? Because if I'm not mistaken, New York is using SCMS from ISS?
Yes, and once again, we would have seen a large number of denied BSM messages because they don't have our SCMS credentialing. They probably would not have gotten through. But yes, we would have seen more. The ones we're seeing now are probably the stray cars that have it. And like I said, we're only seeing them basically inside the denied counter. When we go to do general troubleshooting and maintenance, we're seeing more BSMs than we should be seeing in times that we shouldn't be seeing them, but they're always coming in as denied because of SCMS.
Right.
Or without a certificate is actually probably the correct terminology.
Correct. And Kevin, if I'm not mistaken, our neighboring state, Pennsylvania and Delaware, they're both not using security credentialing at the moment?
At the current time, we are, yes, per our vendor, they're not using it, yes.
Okay, so hopefully the question now is the answer is a little bit more clear, because begin with DSRC, there would have been a good amount of penetration. Then you would have, when you go to CV2X, it drops because there are not too many cars with that equipment. You couple that with the SCMS requirement, it just blocks everything out. So at the moment, it's absolutely true. That is the response. If there's anything else.
No, that's it, Wasif. And I see Alan has hopped back on.
Okay.
He messaged that their office entire network briefly went out. So with that, Alan, I'll see if if you're able to speak, if your audio is back.
Yeah. Hey, sorry about that. It always goes down when you don't want it to, right?
Yep, of course. I guess, Kevin Hunt, could you make Alan a presenter again so he could bring his slides back up?
Yep, he has privileges.
All right. I think this is near where I left off or before I dropped out. I am over my cell phone here, so I will keep the video off if that's all right with y'all. So I was talking a little bit about our transit signal priority pilot. We also looked at a freight signal project down here near Port of Savannah, looking at outfitting private vehicles and what it would look like to provide freight signal priority and their ingress and egress into the port facilities, and also providing travel information for when, say, an at-grade rail crossing is blocked so they could have better decision-making entering and exiting the port. We also have a partnership with the Ray on I-85. This is actually a P4, public-private philanthropic partnership. With this organization that we outfitted 6 locations on the interstate to demonstrate some rural-based applications on the freeway, like queue warning, airbag deployed. We deployed OBUs in 4 of our GDOT vehicles with LTE CV2X and pipe in BSMs back into the Panasonic's data platform, Cirrus, to demonstrate these various applications. We just recently expanded this out to 7 signalized intersections in a partnership with Kia Hyundai and their research arm, Hachi, outfitting 10 of their executive fleet vehicles. There's a Kia manufacturing facility right here on this section of road, which makes it a great opportunity to work with them and demonstrate some additional applications in their vehicles, integrated fully into their system and what can be gleaned from that, and also expanding later on into freight priority for their and work zone alerts for vehicles entering their facilities. This is our initial deployment of CV2X in the state, and has been a great learning opportunity for us. So lastly, I just want to talk a little bit about what we see the path forward, and especially with technology. We see the need from transitioning from a broad regional deployment to focusing more of our own, targeting deployments that support public fleet use cases. We're going to continue to work with regional partners to meet their needs, provide our knowledge and resources to expand out connectivity and applications. Things like transit signal priority make a lot of sense for regional opportunities. We're going to continue to hedge on technology as before that gets settled from a regulatory perspective, to continue on this more radio agnostic platform we have, where we are doing a lot of the message creation and modeling and things like that off of the radio itself, and continue just to use the radios as quote unquote dumb radios to really just forward messages and sign them with security. And then continue to look at things like open data. We've invested a lot in platforms to provide open data to all of our systems, especially on the traffic signal side. There's no reason why we can't continue to serve up this information and pipe it out to those non-time sensitive applications. We see this as real opportunity. We've seen tremendous third-party interest in these kinds of applications and platforms, getting this information that has not been available to the world out openly and freely as best we can. And then we see a lot of challenges that are still out there in this space as well. We see the need for continuing work and refining standards. You heard a little bit about the issues with SAE and phases and map message sizes earlier that are all standards issues. A lot of the work in the IT connected intersection space as of late has done a lot to improve this, but there's still much work to do. When there's safety of life applications going on here, we got to get things right. We still feel the need that technology needs to be settled. IOs like us can't afford to be changing radios every 2 years when the next thing comes out. So we think there needs to be some certainty and continuity there for technology. From a spectrum standpoint, we need that regulatory certainty that the dedicated spectrum for these applications will remain and be protected, and so that we can invest and use it for these safety applications. And we still need to see the fleet be enabled. All this investment we have really will do great things for us as an agency in our public fleets, but not until we start seeing the broad deployment of production systems and private vehicles, where we really realize the safety and mobility benefits of V2X. And again, I apologize for having to drop off there for our intermittent network issues. And I believe we can get back to questions now. And thank you again for allowing me to participate.
Thank you, Alan. I appreciate that. And I want to thank all of our speakers for the session, Jim, Megan, Wasif, Kevin, and Alan. Before we move on, Alan, there was a question that came through that I'll send over to you. And the question is the connected vehicle equipment being maintained internally or through contracts with the vendors? Is the connected vehicle, is it scalable from a maintenance perspective?
That's a great question. It is currently being maintained by contractors. We do contract out a lot of our maintenance and operations activities for all of our traffic operations world. So that's a common thing for us, and it will continue to be so. These devices too, especially in the connected vehicle space, require a lot more than just is it on or not. They're essentially digital traffic control devices in the way that we use them. So it takes a higher level of not just making sure the light's on, so to speak, on these. So we not only have to bring in the physical maintenance of these things, but also the operational maintenance. And then that's something we have been and will continue to contract out. Fortunately for us, from a scalability standpoint, we're in a position to support that. But the political winds can always change those priorities within an agency like ours.
Gotcha. Thank you, Alan. So with that, I would like again thank all of our speakers. And before we take our break for the next session at 1, I'll turn it over to our conference chair, Amber, who will be running the raffle for some giveaway prizes.
Thank you, Drew. And I want to say thank you to everybody who has stayed on the line so far. We really appreciate you working through with these technical difficulties, especially as we know all these storms are running through the area from the remnants of Ida. But we have 2 $100 Visa gift cards that we will be raffling off right now. The first one, we thank McCormick Taylor, our member, for that gracious gift. Congratulations, Rocco. The gift card. All right, and then we have a second gift card for $100. We thank you, Jacobs Engineering, as well for that. All right, congratulations, Sean Walsh. Again, thank you everybody for sticking around. Please join us back at 1 o'clock for ITS America's Ron Thaniel to give us an understanding of what's going on at the Hill, and then as well at 2 o'clock for our PA regional updates. Have a great lunch, everybody.